Hello and welcome back to a brand new video. Today we are going to learn how to convert a binary value to a decimal value. In our last video, we saw how to do this in a mathematical way, and I gave you mathematical expressions on doing these. Now, in this video, we're going to learn how to do it with code. Now, there are two basic ways to do this. There's an iterative way and a recursive way. In this video, we will be doing the iterative way. In the next one, I'll be showing you guys how to do the recursive method. If you have any mathematical doubts for this and you still haven't seen the last video in which I discussed the concept mathematically, be sure to go and check that out. The link would be in the description. But wait, before we begin, I have something very important to discuss. More than 96% of you that watch these videos are not subscribed. This is my humble request for you to subscribe. It helps this content reach more people and aids my goal to spread code literacy. P.S. If you're the part of the elite 4%, you are helping change this world. So thanks for that. Now let's get back to the video and learn how to convert a binary value to a decimal value iteratively using Python. Alright, perfect. So we have our code editor open in front of us. My code editor of choice, as you all know, is Visual Studio Code. So to do this iterative method, we simply have to create a function first since we're using Python. So let's define our function. Let's name it binary to decimal. And now our function is converting a binary value to a decimal value. So all that we really need as an input is the binary value. So let's just name it binary. And since we are converting the binary to a decimal value, we need to initialize a decimal variable. Let's call it decimal and give it a value of 0 for now. And another thing that we need for the iterative method is I, that would be basically the number of iteration. So let's keep it at 0 because that would be the base. Now let's come down to the logic for the iterative method. We'll be using a while loop. So as long as the binary value is greater than 0, a loop should go on and it should keep going on until the binary value reaches 0. So that is the iterative method where we go through each and every case within a loop. That is iteration basically. So I have explained everything that we're going to do in this in the mathematical video that talks about how this works. So I'm quickly gonna get down to coding. So we need our last digit, which would be the last digit of the binary value. Suppose our binary value is I'll write it here. For example, our binary value is 1010110. Now this is a random binary value that I have given. It could be of any length. It does not matter with this code. So the last digit would be this digit, and we are basically going to find that out. To find that out, it's really simple. We're going to use the modulus function. So we'll say binary modulo 10. This basically gives us the remainder on division with 10. That would be our last digit. Now what we want to do is decimal would change to, actually the value would increase to last digit times 2 to the power of I. So since the last digit has, so as we all know, obviously each of these bit has a power of 2 connected to it. So the last digit right here would have the power of 2 to the power 0, this one 2 to the power 1, and then this 2 to the power 2, and so on. So we basically say 2 to the power of I, where we already know I is currently 0 for the first iteration. And then what we want to do is we want to change the value of binary. We'll change that to binary equals to binary, and we'll flow divide it by 10. This gives us the quotient. Now, in the first case, obviously, since the last digit is 0, it wouldn't matter with the modulo and the floor division because it has a perfectly divisible value. But let's quickly change that up to be a 1 at the end. So in the last digit we would get the value of 1, and in the binary we would get the value of 10101110, and it would not give us any decimal value after that because we are doing a floor division that gives us only the quotient of this division. And once we are done with that, we'll just say I plus equals 1, since each power of 2 increases by 1 as we move towards the left. We are just gonna increment the value of I with 1 after each loop, and now that's done. The loop will automatically break when the value of binary becomes uh, equal to 0, or yeah, when it becomes equal to 0. So that would be when we are on this binary value of remaining just 1, and when the binary value is floor divided by 10, it would give us 0. So the loop would break. So that would solve everything for us. Now obviously, now that we have calculated it, we need to return that value. So let's say return decimal, and that should sum up the function to convert binary to decimal. Now let us quickly make it a little more clean and appealing to the user and add a little presentation to it. So let's say binary equals int input, and let's say enter a binary value, and let's print out the result as let's say decimal equivalent and a colon space, and then let's just say binary to decimal right here. And since it needs a parameter, let's give it the binary that we just recorded from user input. Okay, so the code is done. Let's quickly run this and check if it works. Alright, so our code asks us to enter a binary value. So let's use this binary value that we gave the example with, 101 011 01, and we get the decimal equivalent to be 173. Now you can check this yourself using the mathematical explanation that was given in the last video. This is all for this video, and I'll catch you in the next video where we are going to discuss the recursive method for this. Until then, goodbye.